Welcome back to TV Escuela of Davao de Oro. I am Sir Jessiejem Celis, your teacher from Nabunturan National Comprehensive High School, Integrated Senior High School, Nabunturan West District. And as usual, I will be your pre-calculus teacher. To start our discussion for today, please prepare your modules, your reference, your paper, and your pen. So, fasten your seatbelt and let's start. For the past weeks, we tackled some parts of the trigonometry. How to graph trigonometric functions, how to solve problems involving right triangles, and about circular functions. We knew some important applications of trigonometry into our real-life situation, such as navigation or even in astronomy. But today, we'll be discovering new topics involving the trigonometric equations, and that is trigonometric identities. In this topic, you will be able to learn how to determine whether an equation is an identity or conditional equation. Second, apply trigonometric identities to find other trigonometric identities. And lastly, solve situational problems involving trigonometric identities. All of these objectives will be achieved that today because I know you're doing your best. These are some of the commonly used words in mathematics. We have expressions, equations, solution, no solution, and infinite solution. If you talk about expression, it refers to a combination of a variable and a numbers with specific operations. These are some of the examples of expression. We have 4x plus 5, cos theta tangent theta, and sine theta. While for the equation, it is a statement that two expressions are equal. Example, x plus 2 is equal to 9. 11x is equal to 5x plus 6x. X squared minus 2x minus 1 is equal to 0. And sine theta is equal to 1/2. And for the solution, simply means that numbers that make the equation true, that is a solution. Then for infinite solution, it is an equation with many solutions. But if there is no answer, that simply implies that there is no solution. Remember, equation is a statement that two expressions are equal. It has two types, the identity or identical equation and the conditional equation. A sort of examples, we have to consider these two groups of equations, the group A and the group B. For group A, we have 2x is equal to 4, then we have quantity x plus 7 squared is equal to x squared plus 49, and x squared all over x minus 2 is equal to 2x minus 1. While for the group B, we have x squared minus 1 is equal to quantity x minus 1 times quantity x plus 1. Then quantity x plus 7 squared is equal to x squared plus 14x plus 49. And x squared minus 4 all over x minus 2 is equal to x plus 2. Group A is considered as conditional equation, and group B is the identical equation. If you talk about conditional equation,
It is an equation with some values of the variable in the domain do not satisfy the given equation. For identical equation, it is an equation that in which the two sides are equal. To make it easier to understand, when both sides of the equation are equal, then it is said to be identical equation.
In the table given, we have this example. 2x is equal to 4. If you're going to simplify that by dividing both sides by 2, we come up with x is equal to 2. Since there is a specific value in the given variable, so we can say that the example is conditional equation. For quantity x plus 7 squared is equal to x squared plus 49, simplify that, and by transposing all the numbers from the right side to the left side, then change the sign, we come up with 14x is equal to 0. Divided by 14, both sides, and that is x is equal to 0. Then we can say that the example is conditional equation because the variable x has a specific numerical value. For number 2, we have x squared all over x minus 2 is equal to 2x minus 1. Cross multiply and simplify. So we have x squared minus 4 is equal to quantity 2x minus 1 times quantity x minus 2 multiply, then x squared minus 4 is equal to 2x squared minus x minus 4x plus 2. Simplify and we come up with x squared minus 5x plus 6 is equal to 0. The factor of this equation is x minus 2 and x minus 3. Then equate to 0 using 0 property of quality, and that is x is equal to 2, x is equal to 3 with a specific numerical value. And we can say that the given example is a conditional equation. For our identity examples, we have x squared minus 1 is equal to quantity x minus 1 times quantity x plus 1. If you're going to multiply the left part of the equation, you will come up with x squared minus 1 is equal to x squared minus 1. Since they have the same expressions for both sides of the equations, then the equation is identical or identity equation. You're going to continue simplifying that equation, you will end up with 0 is equal to 0. For quantity x plus 7 squared is equal to x squared plus 14x plus 49, expand the left part of the equation, which is quantity x plus 7 squared, and that is x squared plus 14x plus 49. Since they are equal, and therefore, the equation is identical or identity equation. For last example for our identity equation, x squared minus 4 all over x minus 2 is equal to x plus 2. Cross multiply and we will have x squared minus 4 is equal to quantity x plus 2 times quantity x minus 2. Simplify the right side of the equation, which is quantity x plus 2 times quantity x minus 2. That is x squared minus 4. Then they are identical because both sides of the equation are the same or equal. For our next example, I want you to solve this equation. All you have to do is to identify whether it is identity or conditional equation. So I'll be giving you 30 seconds to solve and justify your answer.
For number 1, 4x is equal to 8. For number 2, x squared minus 4 is equal to quantity x minus 2 times x plus 2. Then for number 3, 4x is equal to 4 quantity x minus 1
plus 4.
Timer starts now. Time's up! Very good! Now, let's check your answer. For our first example, which is 4x is equal to 8, simplify that and we have x is equal to 2. Since there is a specific value for variable x, that is a conditional equation. For number 2 problem, x squared minus 4 is equal to quantity x minus 2 times quantity x plus 2. By simplifying the right side of the equation, that is squared minus 4, since they are equal, then that is identity equation. Then for the last example, example number 3, which is 4x is equal to 4 quantity x minus 1 plus 4. So through simplifying, that is 4x is equal to 4x minus 4 plus 4. And after that, we will come up with 4x is equal to 4x. Therefore, the given problem is identical. So, very good, you're right. In trigonometry, we have trigonometric identities. The most common identities in trigonometry is the fundamental trigonometric identities derived from the right triangle. We have sine theta is equal to 1 over cosecant theta. And its reciprocal is cosecant theta is equal to 1 over sine theta. Then cos theta is equal to 1 over sec theta. And the reciprocal of this is sec theta is equal to 1 over cos theta. And tangent theta is equal to 1 over cot theta. Then cot theta is equal to 1 over tangent theta or tan theta. These are the quotient identities. Tan theta is equal to sine theta over cos theta. And cot theta is equal to cos theta over sine theta. Then we have Pythagorean identities, which is sine squared theta plus cos squared theta is equal to 1. And 1 plus cot squared theta is equal to cosecant squared theta. The question is, how they get these fundamental identities? Let's find out. To prove the fundamental trigonometric identities, we will visit the circular function having an angle of theta with radius. Then we draw a right triangle with a side of x, y, and r. R is our hypotenuse since it is in front of the right angle. So using stochastic, we can identify what is our sine theta. Remember, so means sine is equal to opposite over hypotenuse. Ka means cosine is equal to adjacent over hypotenuse. And tua means tangent is equal to opposite over adjacent. Now we can identify what is our sine theta, cosine theta, and tangent theta. For sine theta, we have sine theta is equal to y over r. For cos theta, that is equal to x over r. And for tangent theta, we have y over x. Then for the Pythagorean theorem, we have x squared plus y squared is equal to r squared. Using indirect proving method, we will prove tangent theta is equal to sine theta over cos theta, if it is identity or not. Since tangent theta is equal to y over x, sine theta is y over r, and cosine theta is x over r. So by simplifying the right side of the equation, we come up with y over x is equal to y over x. Therefore, the tangent theta is equal to sine theta over cosine theta is an identity. You're doing good. That is great. How about for Pythagorean identities? Let's try. Let's go. For sine squared theta plus cos squared theta is equal to 1, sine squared theta is the same as sine theta squared. So we can say that since theta squared plus cos theta squared is equal to 1, after that, substitute the value of sine theta and cosine theta, which is y over r and x over r, respectively. Then, we have square of y over r plus square of x over r is equal to 1. Simplify x squared divided by r squared plus y squared plus r squared. We can say that x squared plus y squared is equal to r squared. Then, r squared over r squared is 1. So we have 1 is equal to 1. We can say that they are identical. That's great. We are doing good. Are you excited with the next example? It's your turn. Now, for another trigonometric identity, prove tangent squared theta plus 1 is equal to sec squared theta. Within 30 seconds, prove this one, if it is identity or not. Timer starts now. Time's up. Let's check your answer. Substitute the value of tangent theta and secant theta. Then we have square of y over x squared plus 1 is equal to squared of r over x. Simplify y squared plus x squared all over x squared. Then we knew that y squared plus x squared is equal to r squared. So, that is r squared over x squared is equal to r squared over x squared. And they are identical. Very good. They're showing improvement. We prove the fundamental trigonometric identities using indirect proving. Now, we will solve some of the trigonometric identities using the fundamental trigonometric identities. But in this case, we'll be using direct proving. In proving trigonometric identities, these are some of the techniques. First, we will use the fundamental trigonometric identities. Second, express in sine and cosines without radicals. And lastly, we can manipulate either the left, right, or both part of the equation. For example, number 1, we have cos theta times cosecant theta is equal to cot theta. All we have to do is to convert the term cosecant and cotangent into sine and cosine term. We have cos theta times 1 over sine theta is equal to cosine theta over sine theta. And simplify. So as you can see, they have the same terms for both sides of the equation. Then, the given example is an identity. Next example is cos squared theta minus sine squared theta is equal to 2 cos squared theta minus 1. In this case, you can manipulate either the left, right, or even the both sides of the equations. For my example, I'm going to manipulate the left part of the equation. So in this case, our left part is cos squared theta minus sine squared theta. Using the Pythagorean identity, which is sine squared theta plus cos squared theta is equal to 1, solved in terms of sine squared theta. So we have sine squared theta is equal to 1 minus cos squared theta. Then, substitute the value of sine squared theta, which is 1 minus cos squared theta. Then remove the parentheses and simplify. And cos squared theta minus 1 plus cos squared theta is equal to 2 cos squared theta minus 1. We come up with 2 cos squared theta minus 1 is equal to 2 cos squared theta minus 1. Then, they are identical. How about if we're going to manipulate the right part of the equation, which is 2 cos squared theta minus 1. By expanding the 2 cos squared theta into cos squared theta plus cos squared theta, then substitute the cos theta in Pythagorean identities, which is 1 minus sine squared theta. Substitute that into cos squared theta of the right part of the equation. So, cos squared theta minus sine squared theta is equal to 2 cos squared theta plus 1 minus sine squared theta minus 1. Simplify the right side. Cos squared theta minus sine squared theta, since it is equal, then it is said to be identity equation. Next we're going to manipulate both sides of the equations. Let's try. Cos squared theta minus sine squared theta is equal to 2 cos squared theta minus 1. Then we can convert sine squared theta using the Pythagorean identities. That is for the left side. For the right side, expand 2 cos squared theta into cos squared theta plus cos squared theta. Then cos squared theta minus quantity 1 minus squared theta is equal to cos squared theta plus cos squared theta minus 1. Simplify, and we come up with cos squared theta plus cos squared theta minus 1. That is equal to cos squared theta plus cos squared theta minus 1. Then, they are identical or identity equation. Very good. For this example, I want you to solve sin y plus sin y cot squared y is equal to cosecant y. Solve this in just 30 seconds. Timer starts now. Time is up. Let's check. As you can see, we can manipulate the left side of the equation since it has more terms than the right side. Factor out sin y plus sin y cot squared y. Then we have sin y times quantity 1 plus cot squared y. Using Pythagorean identity, which is 1 plus cot squared theta or 1 plus cot squared y is equal to cosecant squared y. Don't be confused of the variable. You can change the variable. Instead of using theta, you can use y. So sin y times quantity cosecant theta, we'll know that the reciprocal identity of cosecant theta is 1 over sin theta. Then we have sin theta times 1 over sin squared theta. Simplify, and we come up with 1 over sin theta. Then convert this into its reciprocal term. So we have cosecant theta is equal to cosecant theta. Very good. Amazing. Did you know that the subject called trigonometry in ancient times, the sole purpose of trigonometry was to solve triangles, especially those involved in astronomical observations? It was not even considered a mathematical discipline separate from its auxiliary rule in astronomy. It was only in 1400s that trigonometry began to be recognized as an independent area of study, thanks to the De Triangulis Omnimodis of Johann Regiomontanus. However, the actual word trigonometry first appeared about a century later in 1595 in a work of Bartholomeus Pitiscus. I think that will be all for today. I hope you learned a lot for discussions. I know you are doing good with your studies. That's why, dito sa TV Eskwela, sa pag-aaral, sama-sama! Bye-bye!